So the first thing I like to do when I get any kind of Harbor Freight tool is stick the manual in a vise, like so, clamp it down tightly. We don't want it flying all over the place. And then I like to take a propane torch and just go to town. One, for luck. Two, because we're absolutely not going to need this manual. You see how fast that went up in flames? Typical Harbor Freight quality. No, I'm just joking. I love Harbor Freight and I go there several times a week. This was just a PDF copy of the first page. I'd never burn a real manual. So before we get started, I just want to say that the LEDs that I use, RGB LEDs that I use at the top, are actually functional. And I added them so I have a visual indicator of when the unit's plugged in, because I don't like keeping things like this plugged into the wall at all times. I want to be able to know when it's on or off and unplug it as needed. This part of the video is really just a visual overview to give you an idea where everything's located and how everything is working when it's completed. These are just some magnetic cable tie holders that I designed, and they're movable, so you can put them wherever you want. Here it is with the lights turned off. It will probably never get used with the lights off, but it goes back to the fact that the LEDs are a great visual indicator to tell me when the unit's on or off as soon as I turn my shop lights off. So the VFD section of the drill press is mounted to the left of it here, and it just controls the speed without totally reducing the amount of torque. And I did this so I wouldn't have to change belts all the time to reduce or increase speed as needed. One other nice feature is that it takes 120 volts in and then spits out three-phase 220 for the three-phase motor, which is a Baldor CEM 3545. Here we are at Harbor Freight checking out the 13-inch models of their drill presses. They're basically identical. The floor model and the benchtop model both have identical heads except for the sticker, and the only real difference is their height. So if you're following along with the tutorial part of this video, just know that you can use either one. They both accept the same mods that we're going to be doing. And that's why I created this video. It's a ubiquitous model that anyone can go to Harbor Freight and buy, and the mods are pretty accessible. Most of the equipment can be purchased. A lot of the videos that I've seen that are out there already, they have older drill presses or they do drill press restorations and then add a VFD. And I love those videos, and that's part of what inspired this video. But I wanted to create a video that allowed people to work step by step from a tutorial. As you'll see, most of the parts in this tutorial are basically bolt-on with the exception of the VFD mount. There's a little bit of welding, but you know, that could always be modified to work with whatever you have on hand. So this drill press comes with a drift key, and that's just the wedge there, the metal wedge you can stick into the drift key hole and lock the spindle. So whenever we're removing it here, it stays in place and doesn't spin around. We use a 24 millimeter socket to remove the bolt off the top there. And like with most drill presses, it's clockwise to remove the bolt, to loosen it and get it off there, and then counterclockwise to tighten it, which is the opposite of most bolts. So keep that in mind. So this is a gear puller that is sold at Harbor Freight in a 3-pack. This is the 8-inch model in that 3-pack, and I'm just using it to remove this pulley here, which is the one attached to the spindle. This is actually one of the easier parts, that center pulley there, that just comes right out. Then you use a hex or Allen key on the rear motor mount pulley there, and that also just pops right off. Very easy. And that's one of the benefits of buying a new drill press, is that nothing is seized or rusted and everything just comes right off as you need it to. Here I'm showing you some of the mechanical aspects of the drill and how they work from an inside perspective, and that's actually why I added the plexiglass to the top, not only as a cover, but to allow you to peer in and see what's going on inside the drill press. So there's no name badge or nameplate on the motor itself, but it looks like it's a 56 style frame with 4 holes. It's super easy to unmount that, and that's what I'm going to do here in the next part. The shaft is just a standard 5/8 inch shaft. So these are the boxes for the new ball door motors that I got. I got them off of Marketplace for $150 a piece, which is an excellent deal if you look at how much they cost new. They're the CEM 3545s. They've got a NEMA 56C frame. They're 3450 RPM. They're three-phase, and they can be controlled with a VFD, which is the most important part here. This is definitely one part of the project that you could go cheaper on. I got a great deal on these ball doors, but if you were to buy them new, they'd be around $500 or $600. So I would say there are some on Amazon, three-phase, 1 horsepower or 3/4 horsepower motors that would be good. When you're looking for these, try to find one that says VPWM ready or VFD ready. Ball doors technical term is VPWM, but it could vary from brand to brand. Since a new motor is also 56, it mounts right up to the original bolt holes, and there's really no modding necessary to make it fit. It does stick up a little bit more, and we'll get into that a little bit later, but for the most part, like I said, it just bolts right on and fits like a glove. So the first connections here are the white, black, and red. Those go to the motor. That's the three-phase connections. Then there's the ground in the middle, and then you've got your hot and neutral for 120 volts AC coming in on the end there. This is just a little speed test that I did to make sure everything was working before I mounted everything up. Oh, and I do recommend definitely crimping your wires with spade terminals. It makes everything a lot easier. This is the strain relief cord connector. I got several of these. I think I got 3 or 4. They're liquid tight, and they keep water and debris out of the VFD and the motor housing. They just fit in a standard 1/2 inch electrical knockout. And I think they were only about $3 at Home Depot. One thing to note, they really will only work up to the 16 gauge cord. I couldn't get the 14 gauge 4 conductor to work, which is what I used for the motor. But you can actually just take the rubber grommet out of the middle, and it still works for strain relief anyway. Doesn't make it waterproof though. This is the sticker on the ball door motor that shows the low voltage connections. So 6, 5, and 4 are all tied together, and then 9 and 3 are tied together, 8 and 2 are tied together, and 7, 1 are tied together. And I just used Wago connectors to do that, with the 6, 5, and 4 all connected with a wire nut. You can use wire nuts for all of them. I just wanted to try out Wago connectors, and they were actually pretty great. You can look at the high voltage section and see that only a few of the numbers are connected, and it's different because it's actually using 480 volts. That's what the high voltage is, but we won't be using that, so you can just ignore that section. Here are the Wago connectors that I was talking about. You just pretty much snap them into place. There's a pretty big debate on the internet of whether they're good or not good, and for the most part, I had zero trouble with them, and they worked really well. Everything just clicked into place. You can see in the back there I used that wire nut just to get the other 3 together. I could have used the Wago connector, but I just did not. Here's the installation of the electrical outlet that I added. I have the VFD connected directly to the outlet from the inside, and the 2 outlets are for a 5-volt USB adapter for the LEDs, and then I think it's a 12-volt for the tachometer. but you can actually use anything from 9 to 15 volts on that tachometer. Here I am buttoning up everything on the outlets. For the next part of the video, the metalworking section, I'm just going to let it play out because it's more entertaining that way and pretty self-explanatory. I didn't show it, but I've already mounted the VFD mount to the motor mount there. Now I'm installing the VFD. Here I'm doing a pencil etching of the top of the drill press, and this is something that I'm going to scan later so I can make the top panel the LEDs mount to. I feel like this is an underutilized technique, this pencil etching, and it's not completely accurate, you know, but it's good enough for a top panel. This is where I scan the etching into Windows XP, good old XP here, and I just use Photoshop for the scanning process. Try to get it as straight as possible. Then I import it into Illustrator and vectorize the whole thing and laser cut it. Here it is with the laser cut piece. I am drilling a hole in there for the tachometer sensor because that wasn't something that I had planned out too well in the laser cutting, and I didn't know exactly where I was going to put it. So here I am positioning it and making sure it's going to be right over the pulley where that rare earth magnet is. The rare earth magnet actually just passes over the sensor, and every time it passes over, it creates a rotation per minute value. And the magnet itself is just JB welded onto the bottom of the pulley. I wanted to get a good idea if the tachometer that I added was actually accurate. So here I am putting a piece of reflective tape on the spindle, and I'm going to test it with a battery-powered tachometer to get an idea of how close they actually are to each other. And it turns out they're right next to each other, just 1 or 2 RPMs difference, so I feel like I can trust the one that I added. For at least half of the project, I've actually been able to use the drill press to drill holes in the metal and other parts for the rest of the project, and this is a really good example of that right here. It works great, and this is just another cheap Harbor Freight step drill bit. It's going through it like butter. Here I'm just adding the power switch for the tachometer in that hole that I just drilled, and then doing some crimping. Love to crimp. I laser cut some Delrin for a front panel case for the tack. Delrin cuts really easily and it's super sturdy. You can't paint it though, but I can live with that. Here I am just doing a run out test, and it's only getting 0.01 millimeters at the top of the spindle. In the drill bit itself, it's closer to 0.03 millimeters, but again, for a cheap Harbor Freight drill press, I'm totally satisfied with that number. Don't normally say stuff like this, but do be careful out there. I took the pulley guard off because it was just in the way of this new motor. It sticks up just a little bit further, but after the case had been off for a while, I decided I really liked the look of it, the open look, and I like being able to see inside the drill press. But it definitely is more dangerous. So I'm gonna try not to grow my hair out too long to get caught in there. But yeah, overall this project turned out just great, and I can't wait to use it in my shop. So if you have any questions or comments or anything, leave them down below, and I will get to them as soon as I can. But yeah, until next time.